Assalamu alaikum students. I'm sharing this video with you with the purpose to explain you the recent quiz which I have announced, inshallah, which will be held tomorrow. In that quiz, I'm gonna ask you about displacement time graphs and velocity time graph. So this is the homework which was given to you, and inshallah, I will try to revise the whole concept with my explanation on these two graphs. Okay, so this healthy discussion will be very helpful for you for the complete conceptual understanding of displacement time and velocity time graphs. So the question which I have chosen first to explain you, that is based on velocity time graph. Okay, this is velocity time graph, and you all know velocity time graph has two important things. And in velocity time graph, we have, this is time, this is velocity. Everyone knows the velocity can be positive and velocity can be negative. That's why I have shown a positive velocity and a negative velocity. Time cannot be negative. So in a velocity time graph, you have full y-axis, positive y-axis, negative y-axis, but you take only positive x-axis because x-axis, along x-axis, you have time, and time is always positive. In velocity time graph, guys, if you have a slopy line, that slopy line represents constant acceleration. If it is a positive slope, that is constant acceleration above the graph. If it is a straight line, then it is a constant velocity. If it is sloping down, then it is constant deceleration. But if the graph is above the x time axis, look at that, the graph is above the time axis. If the graph is above the time axis, my velocity is still positive. So when the velocity is positive, it means the body is moving in one direction. But this is the point where the body will make a U turn, or the body will stop for a while. So here the body started the motion with a rest. So first it was accelerated, then constant velocity, then constant deceleration. Suppose the body took some rest here and makes the U-turn. So when body makes the U-turn, then the graph will definitely go down. You can make a same the here the deceleration. You can move with the same acceleration magnitude wise. But anyways, the body will go back go back with some acceleration. So this is now constant acceleration, not deceleration, acceleration. And maybe after that, the body is moving with a constant velocity in the opposite direction. And again, look, this slope, the positive slope below the time axis, it will show constant deceleration. And then the body will stop somewhere because now the graph reaches to the time axis. Two important things. Number one, the rise over run in velocity time graph shows constant acceleration, number one. And number two is area under the graph. Area under the graph represents what? Displacement or distance. Suppose if in the exam I find this area A1 and this area A2. So if I want to find distance, then distance is A1 plus A2. But if I want to find displacement, then I will write A1 minus A2, because that area which is found below the time axis, I need to write minus A2. All these things we discussed in the class. Now let's start with this question number 10. I hope inshallah everyone will understand the velocity time graph through this question. So let's start with it. Um, a ball is thrown upwards at a speed of 20 meter per second. Guys, can you check that? The ball is leaving the hand with 20 meter per second. Definitely, when you throw the ball in the air and the ball leaves your hand, it will start decelerating. Look at that. It will start decelerating. Decelerating means the speed will be decreasing. And after 2 seconds, the ball will will make a U-turn. So where I am standing, look at that, at 20 meter per second from a tower which is 25 meters high. So why not I can make a small tower. This is my tower, and I'm gonna throw from here with a speed of 20 meter per second. And this is the point where the body reaches to the greatest height, and that time is t is equals to 2. Because 2 at t is equal to 2 seconds, the body makes the u-turn, and then it comes back. Look at that, guys. The same magnitude of the acceleration, but now the deceleration changes into acceleration. So the body starts going down with an acceleration. Definitely, this is your ground. This is your ground. And now it will hit the ground with some velocity. Let me read it. It goes up into the air and then falls all the way to the ground without hitting the tower. When it reaches the ground, it bounces back with half the speed. Wow. So it means if it is hitting the ground with v1 speed, when it was going down, it bounces back and go up. With which velocity it will go up? With velocity v2. Surprisingly, my friends, the velocity here when the body was going down, and when it starts moving up, because upward direction of the velocity is positive, and when the body is going down, the velocity will be negative. So you saw that your v1 was negative, but v2 is positive because it is going down. That's why the graph from here suddenly it goes up here. But this magnitude is half of v1. After that, same situation happens. Guys, it goes to the maximum height, the greatest height. This is the greatest height where the U-turn will happen. And then it comes back to the ground and then stop. So this distance is the same as this distance, because this is the distance covered here in the upper triangle and this is the distance covered in the lower triangle. So I hope everyone understood the question through the graph and through the real life scenario. Let's read. Guys, acceleration due to gravity in 9709 is minus 10. When it is going up, the body is slowing down, the value of g is negative 10. Look at that. This is negative 10. But when it makes a U-turn, the value of acceleration is 10. Here it is, yes, come on, minus 10. And here it is 10 meter per second square. So acceleration due to gravity is 10, magnitude wise. But when the body is going up, it will be slowing down. So the value of g will be negative. And when the body is coming down, the value of g will be positive. So I have read the whole statement. And in mechanics, the most important thing is understanding of the statement. Let's start reading the very first question. The first question is the greatest height it reaches above the ground. So you imagine when I drew the tower, this is the tower whose height is 25 meter given by the examiner. And now you throw the ball up, it reaches to the greatest height, GH greatest height. And I don't know what is this distance covered. And how I can see this distance? This distance is area under the curve, like a triangle area. So this triangle area will tell you this distance. This distance, d distance, is the area. Okay, guys? So I want to give the answer from the ground. So when I get my D, I will add 25 into it. That will be the total distance which the body has or the ball has covered from the ground. How to get this D? So come to the velocity time graph in this triangle. Everyone knows the area of a triangle. The area of a triangle is half times base. What is the base, guys? The base is 2. And the height is how much? It is 20. So 2 to cancel, and the answer is 20 meters. So, Mr. Omar, the distance covered by the ball from the top of the tower to the greatest height is 20 meters. So may I ask you how much distance is covered by the ball from the ground? You will say, Mr. Omar, you need to add 20 in 25. So the answer is, let me erase everything. Let me erase everything and write my answer here, because the space is less. That's why I'm erasing the diagram and trying to make it neat as I can. So greatest height is, so greatest height from the ground to the top of the tower is 25 meters, plus from the top of the tower to the maximum height is 20 meters. So total distance from the ground is 45 meters. So part A is done. Now let's go to the next part. I will use different color, B. The time it takes to reach the ground. Wow. Let me draw the diagram again. This is the tower. And from the tower, we have thrown the ball up. It goes to the maximum position, then it comes down, crosses the tower, and then come back to the ground. The examiner want what with which speed it will hit the ground. Can you check when the ball reaches the greatest height, the direction is opposite. When the direction is opposite, the graph will definitely come below the time axis. So guys, you check that when we have this portion, our ball was going up. Now the ball is going down, so it means I'm going to talk about this portion. So T1 is the time, boys. T1 is the time when the ball reaches to the ground. Okay, so this area, you understand it? This area is representing this area I'm talking about. This one, right? So can we calculate it? It's pretty simple, guys. It's 45. It's this area is 45. Now let's move on and try to solve the question. The time it takes to reach the ground. The time it takes to reach the ground, we need to know this time. So can this duration is 2. This duration, I can call it T1 minus 2, but I will call it as T1 time. T1, small T1 time. Okay, as everyone knows that this distance is what? 45 meters. And this distance was what? 20 meters from the top of the tower to the maximum height. Okay, everyone, please be with me now. Tell me, this area is how much? 45. Why 45? From the maximum level to the ground. So this was till the tower 20 and the height of the tower 25. So it will travel how much? Total 45. So the height of the tower is 40. Sorry, the maximum height from the maximum height to the ground it is 45 meters. So let us use again the area of a triangle formula. Half time. What is the base, guys? T1 time. What is the height given? Oh, Mr. Omar, we don't know this V1. No worries, man. V1, it is equal to what? It is equals to 45. Bad luck. This 2 will go to the other side and multiply with 45. So T1, V1 is equal to 90. Oh, I don't know what is V1, what is T1. So it means that we are wrong. No, man, you are not wrong. You have to derive one more equation. You remember the gradient. That gradient is already given to you. It is 10. So gradient is rise over run. So can I use the gradient concept also? Acceleration is what? 10. Rise is how much? V1. And run is how much? T1. Can I send it to that side? So it will give me V1 is equals to 10 T1. Lovely. Can I write in place of T1 as 10 T1? So T1 in the place of V1, Mr. Omar is going to write 10 T1 is equal to 90. Now 10 T1 squared is equal to 90. Mashallah, your algebra is strong. 10 cancels with 90. So T1 square is 9. And the square root of 9 is, yani, when I take square root plus minus 3, but minus 3 is ignored. Time cannot be negative, so you just write 3 seconds. Wow, Mr. Omar, we found it. What did you find, man? We found that the ball will come back to the ground from the maximum height in 3 seconds. Lovely. In 3 seconds. So the time it takes to reach the ground. Actually, T1 time he's asking you. So the T1 time is 2 plus 3. And you add all the durations. 2 seconds from the top of the tower to the maximum height. And 3 seconds from the maximum height to the ground. So the total is 5 seconds. Now let me go to the C part now. In the C part, he said its velocity when it hits first the ground. You remember, guys, when from the top of the height, this was the ground. When it hits, that was v1 velocity. So I want to find this v1 velocity when it hits the ground. Oh man, this equation you already have it. We found it. What was that? v1 is equals to v1 is equals to 10 times t1 time. This was t1 time. So 10 times 30. Okay, right? What was this? No, 10 times 3. Sorry. 10 times 3. It is 30. Am I talking about velocity or speed? Man, when the body is going up, velocity is positive. When the body is going down, velocity is negative. If I'm talking about what is the striking speed of the ground, then it is 30. But now it's returning, it's coming back. So the you need to write a negative sign which shows that it is returning back. So minus 30 meter per second is the returning speed when it hits the ground. I hope it clears. D, next part. Oh, its velocity when it rebounds. Great. Look at that. This is the tower. From the tower, it is thrown up. This is the ground. It takes the bounce and it reaches here, and then it again hits, the second time the ground, and here it stops. He said when it strikes with v1, definitely some of the kinetic energy will be lost. Now when it will go up, its velocity will be decreased. Now the velocity is half of this velocity. So if this velocity is 10, so this velocity up velocity will be 5. So he mentioned it categorically that half the speed, yani the bouncing speed is half the speed when it strikes the ground. So what was the v1, guys? You remember your v1 was 30. So when it will go up, it will be 15. My friends, now why it is 15? Why it is positive? Because you remember when it was going down, it hits the ground, the velocity was negative. But now it is going up, and that is the half velocity. So V1 was 30, V2 was 15, but it should be positive because now the body is going up. So that's why the guy has shown V2 here. I hope it clears. Another important point which you guys have to analyze, did you see that this line and this line, they are parallel? Because the gradient is acceleration due to gravity, which is 10 meter per second square. It stays the same. So whenever you draw the gradients in this free fall motion, your slopes will have the same gradients. Yeah, yani your slopy lines will have the same gradients. Anyways, let's move on to our next part, E part. Beautiful question. He said, now the greatest height when it bounces back. Let me again explain it to you. This is your tower. The ball goes up, touches, yani hits the ground, goes up, and then come back. He wants to know this maximum height. So if you want to know this maximum height, guys, this one must be showing area of a triangle. Wow, this triangle. Bravo. And this triangle, both triangles, up and down, have the same area. So I will be concentrating on this triangle. So this is 2, this is 3. I want to know this time. So can I call it as T2 time? And V2 we have already found that is 15. Wow, 15. Oh, the gradient I have already known. I know that. But can I find the area, because I want to find greatest height, so this distance is to be found. So area of a triangle, half times, come on boys, this t2 time, and the um, height is how much, v2, which is 15, which is 15 is equal to, and this is the area I want to find. So this is the distance or the height is required. I don't know what is t2, but can I use the gradient concept? The gradient is what, 10, v1 is what, 15 over t2. Wow, our t2 is 1.5 by using the gradient concept. So let me erase everything and write here for you, by using gradient, this has to be, this has to be 1.5. So this should be also 1.5, because when the body hits the ground, it goes up, same time it will take. So it means 1.5 second going up and 1.5 second going down. 1.5 and 1.5. uh, Now I want to find this area, guys. This area is required. Come on. Can we do this? Yes, we can do this. What is this? Area, half times base is what? 1.5, and height is what? 15. And the answer comes to us 11.25. Bravo. So this area is 11.25, and this area will also be 11.25 meter. But he's not asking you this question. Anyways, my boys, so the greatest height after bouncing, it should be 1.11.25 meters. The last question is the total time taken for the ball to come to the rest. So the total time, guys, is what? Can you check it out? Till T2 time. Oh, wow, Mr. Can you add everything? Yes, I can add everything. 2 seconds, speak it up. When the body leaves my hand from the tower and reaches to to the greatest height, +3. What was that time? This is the time when the body was at the maximum height above the tower and comes down and hits the ground. After that, we have 1.5 second. This is that time when the body bounces up first time and reaches to the second greatest height, which is 1.5 second. Plus 1.5 when the body was at the maximum greatest height after the bouncing and strikes the ground second time, 1.5 second. Can we add them up? And the answer will come to us 8 seconds. I hope, guys, this discussion was very healthy and helpful for you to understand this velocity time graph. Thank you.